We are back. We're in the right meet now. Clark's going to be talking to us. He's our only lecturer today. He's going to be talking to us about Ruby gems.
Yeah.
Specific testing gem.
Yeah, specifically my gem. I will talk a little bit about some of the things I found interesting about writing a gem in general. But yeah, hopefully you'll learn something. If not, that's fine. You'll have your computer so you can write some good code too. Okay, so first of all, welcome to GitHub. It's called a Grift. A grifter is someone who cons someone, usually by pretending to be someone they are not, or pretending to be someone else, and gaining the confidence of the other person, and then stealing their money. Very neighborly. So it's called Grift. I wanted something small and simple, and it was available. So anyway, so the idea is that it does mocking and spying or stubbing, or the language is confusing because people use this language inconsistently, but basically it's a lot like jest, if you've used jest, in that it'll allow you to simply watch functions I should say methods. In Ruby, they're methods. So it'll let you watch a method to see what the parameters passed in were, what the return values were, but you can also then override that method's implementation to execute a block of code that you specify, or to just return some value if you want to keep it simple. So that's the idea, is it allows you to do all that, and then it records all that so you can, access that data. So when you're writing your unit test, you can make sure that, a method was called with the parameters you expected it to be called with, or that it was called the number of times you expected it to be called. Especially helpful if it's only a part of something that you're testing. It's like a small cog. Or if you're trying to make network requests and you want to stub those out, or S3, some kind of AWS thing, you want to do that, then that's what this tool is for. So it utilizes Ruby's meta programming in order to actually achieve that. So I'll go show you in a bit the main idea behind what's happening. But I wrote this README, so I'm going to make you all look at it. So you can install it like any other gem. One of the coolest parts is you can configure it to use a plugin. So after every test ends, it'll see if anything is mocked and it'll clean it up so that your behavior that you've imposed upon that method does not persist from test to test and cause unexpected results. Right now, with our current solution, you have to specifically unmock every class that you mocked a method for in the test file, but this just cleans it all up for you. So that's pretty cool. So the basic things are, you can grift.spy on, pass in the class and the method. Methods in Ruby, when you want to actually refer to the method, you use a symbol. Otherwise, you'd be calling the method if you didn't include this colon in front. And so it returns an object that allows you to, evaluate all the results and stuff. Here there's mock, which is really just some syntactical sugar. It calls spy on and then mocks the return value, but it's a lot simpler to just do one line, say, I want this method to return this value every time. So you can see that happening here, spy on, and then mock return value. So these end up doing the same thing. To mock the implementation, you can actually pass in a block. So say .mock implementation do, and then this is a block in Ruby, so it's a chunk of code that will execute. The last value is what gets returned, the last line. You can also specify the parameters that it will take in. Now, if you mock the implementation to accept a different number of parameters than what your method's going to be called with, then you're going to get a bunch of errors because it's going to call a method with too few arguments because you've changed the definition of the method to have a different number of arguments. You can also do wildcard star args here and it'll just be an array of whatever size, and it won't throw errors. So I also made sure that there was chaining, so that every time that you call another, like I want to mock the implementation or I want to mock the return value, the thing it still returns back down to that main mock method object that stores all the right data. And then, like I said, you can call .mock.count calls and results. That's an exact copy of Jest's syntax for now. I might go change it because as I was using it, it was kind of cumbersome to write the word mock. I feel like you don't actually need to do that. So anyway, and a guide for how to develop for it. So if you want to contribute, feel free. It is open source because that's fun stuff. And it's well documented. So that was another thing. I feel like any open source project should be well documented. So you can go look at the docs, uses GitHub pages, and uses yard doc. So it just generates this with a command. It's pretty nifty. So you can go see things. You can link between things. Anyway, so, I documented it all. That was one of the longest parts, actually. So let's go look at what it's actually doing and make this an interesting presentation instead of a lecture. We're going to have to make this bigger, probably.
Yeah, I was going to ask you that. By the way, there's been 368 downloads in your gym.
368? Is that right? I thought it was 435.
Stars.
Well, this is from the Ruby toolbox.
Yeah.
I don't know the whole ecosystem, what repos exist.
476. Most of those were before it did anything, back when it was this version. You also notice that, that must be UTC.
There's 1 or 2 stars.
Do you just keep deleting and downloading over?
Deleting and downloading? No.
Your camera?
People scraped them, and there's a place that generates documentation for all Ruby gems, and so it's just grabbing all of them. And every time you visit it at the gem, it'll go check if there's a new version, and on the fly, go generate that documentation in the same style I was showing you. So that causes.
Well, it's pretty impressive. It says that you have a 90% issue closure rate.
I do.
And an 84% pull acceptance rate.
Only 84.
You're not accepting all your own pulls?
Well, you see, I set it up to go to the wrong branch 3 times. Anyway, so here we go. Get rid of that right now. We don't really need a terminal right now. Does it need one more, or is that big enough?
It's good.
Okay. So the main thing is everything has to be stored in the right namespaces when you're creating a gem. We don't have that problem in Rails because we're not executing our Rails code as a contained package. So everything ends up falling under this module Grift. A class is a more specific module. So anything that's a class method or a class variable should be a module variable. But so this mock stores the cache so that we know what is mocked and what isn't. And then this weird syntax basically says, within this module, now define a class, and everything in here is going to be a class method or a static method instead of an instance. You can't initialize. You can't do grift.new. There's no constructor or anything like that. It's purely static.
So why is line 32 class with a K?
Okay, so line 32 is class with a K because everywhere that you're passing in a class, we need to use not the word CLASS because it's a keyword in Ruby.
Well, that was a comment, but it's probably for documentation
Yep,
reasons?
so it's a param.
Got it.
And so, the yard doc takes this documentation to generate those docs that I was showing you. And so we already talked about mock and spy on, and you can see when I said syntactical sugar, I wasn't kidding. It literally just calls spy on and then mock return value. So has a bunch of stuff in here. This isn't the interesting part. It does allow you to clear, reset, restore all the mocks or all the mocks for a class. Checks if stuff is restricted. I can get into that in a minute. Let me know if you're finding this too boring, and I'll try to adjust. Okay,
Can you sing it for us? Is that?
let's do the. Here's mock method. So when you call .mock or .spyon, every time it's returning, or mock implementation, it returns a mock method object. And so this class is kind of like the core of what's happening in Grift. And so it has a constructor, and I'll go into that into a second. No, we can do that right now. So it takes in a class, a method name, and whether or not to start watching. You could create a mock method that is ready to do mocking, but isn't already monitoring. It hasn't like hijacked the behavior. Because the only way to actually watch a method's parameters and stuff is to redefine the method to first track everything that happened, get the return value, store that, and then just return the return value. And so I wanted to make sure there was a way to get around that and like not overriding the method. You'll notice we have a mixture here of positional and named parameters. In Ruby, it's just a jolly good time. But basically, you can do as many positional parameters as you want first, and then as many named parameters as you want. And then once you've gotten through your positional parameters, it will allow you to do the named parameters in any order, or omit them if there are default values. That was something that was interesting to work on here because we don't really use named parameters in our Rails code.
Wait, positional and named? What's the difference?
I'm doing it more.
So if you pass into the constructor, so you call like Grift : mock method .new, and then the class you want to mock and the method name you want to mock, and you just did that, right? Like it knows class is the first one, it knows method name is the second one.
Gotcha.
But if you wanted to say watch false, you wouldn't do comma false, you'd do comma watch : false. You'd say this parameter that I'm specifying is false. It's kind of like,
it's kind of like an object.
yeah, I was gonna say
Okay.
that's probably the way that would make most sense to you, right? Is if you pass in and you like
JavaScript, yeah.
use you destructure it.
So that could that go first? Could you pass in like watch false?
Not if you have any positional parameters, because it
You have to pass in all the positional ones first,
yeah.
and then
So a lot of people will do like exclusively named or exclusively positional, and that keeps things a little clearer. But it's nice if you do have a bunch of things that you don't expect to pass in, or like you expect to pass in some of them. Because if they're all positional and they have defaults, you have to do like : nil, and then the value.
it's passing the default that makes it a name.
So the default here is true, but it's the named parameter is the fact that I have a colon here. If I did this, it would be a positional parameter with the default of true.
Right. You can also do a named parameter without a default,
Yeah,
and it means that it's a required parameter.
yeah.
Oh, okay.
So it checks if it's restricted first, which is really just, it loads in a YAML file of things that I said you can't mock because it will break Grift. Like if you mock Grift, it'll stop working. Or one that I did this morning, I was testing something, I mocked the constructor for string. And I was in iRuby, which is like an interactive terminal, right? And the terminal broke because it makes a new string after you execute the line. Like it's using Ruby to generate the console stuff. And so it just quit because it's like, I can't perform whatever operation on nil because I told it just return nil instead of a string. So anyway, probably taking more time than I wanted to here. Okay, yeah. So initializes, sets all the instance variables here, sets up a new mock executions class, which is basically a fancy array or hash. I can't remember which one it is. That just is there to store the data and has a wrapper around it so that you can get like calls and results and that kind of stuff. Then what we're going to do is we're going to cache this method, the true method, under a different name because we don't want to lose the knowledge of what the method was supposed to do when we override its implementation. So I did that just by, everything is like Grift _ cache _ the method. It's an easy way to keep track of it. So then it checks to make sure, it checks to see if it's a class method or an instance method. So like static or instance in other languages. And so the way you do this is pretty hacky. Any class you can call .instance methods, and it will tell you all the instance methods, but there's no .class methods. However, if you do .singleton class and then instance methods, it gives you all the class methods. So it checks, because class methods are really instance methods of the singleton class. Who knew? And this true is checking the super, which is part of the problems I was running into this morning. So if you inherit the method from your superclass, your parent class, through inheritance, but you don't explicitly define it, it still exists, but Ruby does make a distinction between it knows when you've defined it or it was just defined through inheritance. And then, yeah, it'll check to make sure, like, if it isn't a class method, make sure it exists in the instance methods. It's kind of a hacky way to do that, but it's just saying, like, we won't let you mock a method that doesn't exist, because that would probably be unexpected if you're like, I want to mock this method, and it's like, you misspelled it. You'd want to know. So it raises an error. Or if it's already mocked, because you don't want to like override the cache with some mock implementation, and then we've lost the true value. So that's really the tricky stuff here, is just keeping track of what is it supposed to actually do, what is it doing now, and making sure you don't like lose that data. So if we actually go look at somewhere where it's mocking it. So it does this pre-mock setup, which is caching the method if it hasn't been cached yet, and sending it to the mock store. So we're tracking globally that this is now a mocked method. So let me go back up. So it does a pre-mock setup, and then we need to, because we're going to be accessing this from within the other class, we need to be able to access the mock methods class variable inside there. So we can't do at mock executions, because it would look for whatever class we're mocking's variable mock executions. So this is kind of like the pattern of, like const me equals this, and then using me when you're diving into something, if you have weird bindings in React. Anyway, so what we do is you can call just .remove method. You can do this anywhere you want in Ruby code. Just say like string.remove downcase, and now you can't use downcase, it's just gone. Or you can remove the constructor. It'll put a warning, but you can just remove methods, which is interesting. So if the method is defined, and this is to check just in case we can't remove the method if it's defined by inheritance. We can only remove the method that's actually defined. So if it's defined by inheritance, we actually just define the method with our fake implementation, because that's just like overriding that method that it inherited. And so if we try to remove it first, it's like you don't have that method. It was inherited. So that was maybe a recent change, as you can see, 6 hours ago. That was why 1.0.2 had to be released. Anyway, so you just define method, you pass in. This is similar to what we saw with when you're marking the implementation, you pass in a block, do, and in this case, you have to just say whatever args are passed in, generally like as an array. And then you can see I'm just storing the args, and in this case, we're mocking the return value. So I actually know what the return value is going to be, because I'm going to return it. So I just say store the fact that it was called with this, and this is what it was returning, and then return that actual value. Whereas if we go to the mock implementation, it has to call the block that was passed into it. So whatever we told what the new implementation should be, it has to call that so we can get what the return value is, because we don't know what it's going to be in this case. Then store it, and then return that return value. And if we're just watching, we do the same thing except we just call the method itself. We just do call or send. I can't remember. Anyway, so that's the like metaprogramming stuff. That's all it is. You're just removing methods and defining methods, or I might have alias method here. Yeah. So when we want to clean it up, we go remove the one that's mocked, and then we say, okay, now alias, this is the same as when we cache, just the reverse operation. We say, I want to call this same method by this name too. And then we go get rid of the cached one. So it's just like this temporary, we have two methods that do the same thing and then we remove one. So that's all the like metaprogramming stuff. And a lot of this internally is just what happens right now with the mock methods, mock method that's defined in our test helper in Rails. But it doesn't have all the nice like wrappings around it. It's not like well tested or anything like that. So this provides more functionality because you can like just watch stuff without actually changing it, and allows you to really easily access that history of what happened. So yeah, that's what happens like internally, which I thought was interesting. So yeah.
And now our testing code is tested.
Show us it in a test.
So yeah. So I wanted to show.
So is this in the Rails API project yet?
I have it in a branch,
Okay.
and I can show that in a second.
How long did this take you?
So it took me about a month.
Over a year, actually. You started on it a year ago, right?
That's true. You started on it a year ago.
Yeah, I wrote the first initial concept and then
Yeah.
took it backwards.
So, and I've been wanting to do something like this for a while. Yeah, so that it'd be more useful and cleaner. The main thing I really wanted to do was have it automatically clean up, because it's just a pain to have to remember to go unmock everything. If you don't, then like your other tests fail, and it's confusing for a minute, and then you remember, and it's like an extra line of code for every
So how
mock
does
we do.
that work, that it knows when to clean up?
Yeah, so I'll show you that. Here we have a mini test plugin. So this is just a module defined under the namespace of Grift, and it is implementing this hook, which mini test exposes these hooks for plugins only. You shouldn't, when you're writing your tests, you shouldn't ever say, after teardown, do this. You can do setup, you can do teardown, but there's before and after setup and before and after teardown that are just for plugins. So what my thing does is, it calls super because you could have multiple plugins, and so just depending on what order they're in, weird stuff happens. So it, and then it restores all mocks, which it's going to go through the mock store and say, okay, what's everything that's mocked, and then it's going to go in and it's going to do that cleanup that I was just showing you.
That was super nice.
So,
I appreciate that.
and I had it originally in before teardown, but I was like, what if they want to see the results in teardown? So now it's after teardown. So this actually means that in a teardown, you could still access the mock, and it's like still mocked temporarily.
Makes sense.
Yeah, so you can add it really easily. This is what you'd normally do export in Rails, so you do the active support test case or whatever, but you just, which is inheriting from Minitest. Minitest is Ruby's built-in like default testing framework. It's not the best one, but it's what we use. It's very simple, so actually in that way it's pretty nice. It's really lightweight, really simple. Our spec is the more commonly used one, and it does a lot of stuff, but it's slower, less customizable, that kind of stuff. And then you can also use Cucumber. So let's see. Some things that were interesting about this gem. So first of all, you have to figure out how to, let's see, you have to figure out how to specify which files should be included in the gem when you run the build command. And this was the way I ended up doing it. So nothing, anything that's not version controlled doesn't come in because it uses Git to actually decide.
Oh, wow.
So this is a very common pattern actually, but it's grabbing all the files that Git is keeping track of. So not just like staged or anything, but just, anything that's not Git ignored basically. And then it returns whatever formats you have to split on this character. And then it rejects anything that matches this regular expression, just in case, because my tests are version controlled, but they don't need to be in the gem. So it gets rid of any test docs, spec, features, that kind of stuff. So that was interesting. It like takes the directory and then expands path, so goes to the right spot, loads all those files, then does this git command. And so that was kind of interesting. I didn't expect to have to use git. I mean, there are other ways to do it, but that's what I went with.
This is simple enough. You could probably specify each file individually, right?
Yeah.
Or
Yeah.
directory.
Yeah, a lot of people just say everything in lib include. I also used Rubocop and specified the Rubocop formatting. So every time that I save, it lints and formats. And I ended up reading through every Rubocop cop. Each one of these is a cop. And this is just the few that I wanted to either do something different than the default or explicitly include earlier than it's in the next release. It's going to be in the default enabled kind of stuff. So that was interesting. I read through like hundreds of them. That took a while too, but I finally decided on what I wanted. And
And now you're gonna put it in our real quick.
maybe some of this, probably not this, probably not any of these, because we'd have to have huge numbers here for any of our stuff to pass. But that was really nice. And again, because it's open source, it's really nice to have that kind of stuff, because then it's just enforced. And I can show you, I have GitHub Actions that run on each push, and it runs, uses Rubocop to actually lint and inspects all the files. And then it actually runs a matrix of Ruby versions. So I've stated that I support 2.5 and up. And so I run it against every version that it should be supported on. And in fact, there was something in 2.5 that failed one time because I used something that's only available in 2.7 on, and I had to go change it. So it's really cool. It just runs, and you can be jealous. 10 seconds. Watch this. Rake test. It just ran all the tests. Finished in 0.007 seconds. If you do that with Rails locally, my machine takes right now 4.5 minutes, and in the CI it takes 7 minutes. So now I'm spoiled.
You're talking about for Rails API.
Yeah, for Rails API.
Yeah, for this, it's still going to be fast on your local machine.
Faster on local machine than CI.
Yeah.
Yeah. So I'm saying Rails is also faster on my local machine, but it's...
It's just nice to be working on a small project once in a while.
Yeah. I mean, I have a lot of tests, relatively. I have 46 tests. But when I started at Neighbor, we had 60 tests in Rails, and it wasn't running in less than a second, that's for sure. Because Rails has so much overhead that has to load first. This doesn't really have to do that. So, but yeah, it's really nice to work on a small project for once. Okay, so we're like 30 minutes in. Any questions on anything I've talked about so far before I show you using it in Rails? Actually, there's one other thing I wanted to show you real quick. Let's see. So another thing, we use this terminal. So I also added this tool here. So there's a binary for console and for setup. So if you do bin console, this starts iRuby in your terminal, but it loads all your project files into it by default. It's like Grift exists. Whereas if you open up normal iRuby, it just has everything that comes with Ruby. So it's pretty nifty. And I'll show you what happens if you do string and new. you can see this is what I was talking about, where I should probably make this a restricted method. Not that anyone would really try to do that for a test, because you get, and it's trying to do some operator on what it thinks should be like an empty string or some other kind of string, and it's not working. But just in general, I can show you, like, if you did right now, if you have banana and you do dot uppercase on it, puts in all uppercase. But if we do grift dot mock string uppercase, and we say apple, oh no, oh, I did IRB. Sorry, everyone. That's what. And now we do banana uppercase, we get apple. So it works. Look at that. Now we do it and we get banana. So we can clear it up. So if we want to look at the Rails project, I can stop talking, you can leave, you can stop paying attention, but I kind of, while I had the microphone, literally, wanted to talk about writing tests with assertions that are more informative. So here I've made this whole little mock project, and if I run my tests, you can see we had one failure, our only test failed. And what did it tell us? Expected false to be truthy. But I know more than that. I know exactly what I wanted foo.speak to equal. So I should have done, assert equal expected, and then what I got. And then I run it, and I get a much more informative response here. Expected this string literal, got this string literal. I'm like, oh, I actually just wrote that test wrong. So let me go update it. Boom, passes. So, however, if I was like, okay, I want to really make sure that it has an exclamation point, that it isn't hello. It can be anything else except hello. But let's say I leave the exclamation point first so that we can see it fail. So this is basically equivalent to assert not equal, right? Except this gives us yet again an even more informative message. We wanted to make sure that foo.speak was not hello exclamation point, but it was. So we expected hello exclamation point to not be equal to hello exclamation point. And so it's just it's making a statement on what you're testing for, and the failure message is much more informative.
So it's sort of like it's like combining the assertion method with assert, right? It's like kind of like expect to be equal.
All of these at some point call assert, but it catches the failure and raises its own failure with a better message. So we can make our own assertions too.
So we can also do a description, a failure description too, right? Do you want to talk about that? Like the last parameter that is usually nobody puts on the refute, just a comma and then a string. So it's like a descriptive. Yeah. So that's another way. If you're having to do like a truthy test, you can actually put a descriptor on it to have it tell you.
So it'll give you whatever the message was and the additional message of like.
Only if it fails.
So
only if it fails.
For this one, you should write something like foo.speak should never equal hello.
If you felt that was necessary beyond what the code says for itself.
Mm-hmm.
Yeah. Yeah. So.
You could just have it say idiot or something.
No. We want to be nice. Although Minitest does have a method that you can add in your test helper to make sure that your tests run in order. If you wrote your tests to need to run in order, which means you wrote bad tests. And the method is, in snake case, I suck and my tests need to run in order, or something like that. So that's them. Anyway, so
that seems appropriate.
There are a bunch of them, and you can look them all up. But like assert empty a, anything like an array or a hash or whatever you write to respond to this method will work. You can also do like refute, include. I think it's include, not includes. And then I want to make sure this is kind of redundant, right? But did I read? Oh, it is includes. Okay, so you can see I said I want to make sure A is empty, and I want to make sure it doesn't include B. In this case, this would make more sense if we had and like. So we've made the assertion. We want to make sure it doesn't include that, which is nice if you're doing like substrings. I've done that before where it's like the method's going to return a string that should or should not have like some ID in it depending on the behavior. Or like it should include this URL or it shouldn't include this URL. And so you can test for things like that. Refute itself is really nice. Like I used that when I was testing a method that does a merge, and if the merge fails, then the model in Rails dot merged should return false. It shouldn't think it merged when it failed to merge. So instead of assert not merged, it's refute merged, and that's just that extra like if it does fail, that one's just expected true to be falsy. That kind of thing. So.
Clark, do me a favor and make that lowercase b and uppercase b and then run your test. I want to see the actual messages.
Yeah. So in this case, it will say that it expected it to not include b, and it tells you like this is the enumerable, and I expected it to not include b.
Yeah, which is nice. It's linked. It doesn't say, it doesn't say includes question mark to be false or anything, which is what you would do without the refute. You would do an assert, right? So it's actually more lexically clear.
Pretty sure you can do this. Yeah, so here you can check this hash. I don't want it to have this key in it. Or maybe I did. I want to make sure that like whatever object or hash I have, I want to make sure it has all the keys I expected it to have. You could run it through a list of keys, and on each of those, make sure that the keys includes that, or just say the hash includes it, and it will look by default in the keys, because this is just anything that responds to .includes or includes. And so there are a lot of them. There's that are helpful for common things, like array inclusion or let's see, mini test assertions. I flipped this up a bunch of times. Yeah, so this is a list of them. Assert in delta. If you have floats, you can check that the two floats are within a certain range, and that way you don't have to know like exactly what it's going to be, because potentially there's going to be some slight variability. We use that in our tests in a couple places. Let's see, instance of, kind of, so you can check what the class is, or inherited class as well. Assert match, so anything that responds to the matcher, so that could be a regular expression. So you could use a regular expression to check that your string matches some pattern. And this one is fun. I did learn many test does have built-in mocking. It's a very naive version of what Grift does.
I think the built-in one doesn't let you mock class methods, right?
Yeah. So you can do assert nil, you can do refute nil, that kind of stuff. It is interesting in the next version of Minitest, if you do assert equal nil nil, it will throw an error. Right now it just says, if you're expecting nil, you should check for nil explicitly. Assert operator. So any operator that returns, like a true, false kind of value, you can pass in between two. So in this case, if like this fails, which it will, 5 is not less than or equal to 4, then you get the message that's like expected 5 to be less than or equal to 4. Instead of assert 5 less than or equal to 4, and it's like expected false to be truthy. So it's way more informative, especially because most of them will highlight the actual data being used, the actual variables themselves.
And you use the operator as a symbol. Is that what that is?
Yeah, so in Ruby, everything is a method or a module or a primitive type. Those are the only things they can be. And so operators are really just methods. That's true of most languages. They're just functions with some special properties. You can overload the operators, you can define them. And so you can refer to any operator this way, which is actually interesting if you're doing a nil check, like safe navigation. And so you have a value that's like potentially nil, but you want to check that it's, like less than or equal to 4. You can actually do this. So that's the safe navigation symbol. And then call less than or equal to with a period as a method, and then 4. Or it's Ruby, so you don't need the parentheses. But same with an array that's potentially nil. If you want to if you want to do the like index access, but you want to do safe navigation, you have to do it that way. So what you're doing here, it highlighted it wrong because brackets are weird, so it's hard to catch. But this is actually calling them as a method. So yeah, you pass it in as a symbol to refer to the method. Just like with all of Grift, when you want to mock a method, you pass it in as a symbol. Assert output. So you could actually have a block that like prints something, and you can make sure it actually prints that thing, which is pretty cool. Assert predicate. Let's see. Assert raises. That's a good one. You can say, I want to make sure this raises this exception. Respond to. So that's every class has respond to question mark method. So you can check if you send this method to the class, will it respond to it or will it throw an error? So yeah, assert same is different than assert equal. It uses a different kind of equality. Can't remember which one. Yeah, so lots of different things that you can use, and you could use any of these in Minitest if you wanted, even the ones that aren't assertions. So you could have your own logic, if this, blah, 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 flunk, instead of using an assertion. So, and then you can see all the refutes. There's pretty much a refute for every assert. But yeah, they're really informative, and I like them a lot. And so now that I'm writing stuff in Go, I've actually looked for something similar and found it. So most of our tests just do a reflect deep equal, but there's something called go deep, which actually returns the diff. So when you throw the error to say this test failed, it tells you exactly what part of it wasn't equal, which was really nice. I had to look for it when I was comparing like 3 massive, I guess they'd be
structures,
structs or interfaces, but basically like an API response, JSON type thing, but in Go, right? So you got all this data, and it's like, those aren't the same. And I'm like, how are they not the same? And in my case, because we were just printing, this is what I got and this is what I expected, they were literally the same because their 2 strings were the same. The difference was one, when it was deserialized from JSON, was turning something into a float, and one was already an int. And so it was able to catch that. It's like, here's the difference. This is an int 64 and this is a float. And I was like, that's pretty cool. So I think the more we can do that in tests, not just in Rails, but across our projects, is great. Although ideally our tests pass, but it's kind of hard to justify this sometimes because you're like, this is only helpful when it fails. But I think tests should be useful when they fail. The whole reason they're made is to potentially fail and let us know that something's wrong. So why not let what went wrong be specific? Anyway, I'll get off my little testing soapbox. Any questions in the last few minutes?
No.
Probably
Thanks,
not,
Clark.
because I was for both.